Right now, as you watch this, a slab of ice the size of Florida is coming apart. If Thwaites Glacier collapses completely, it will reshape the coastline of the United States and displace more than 10 million people living in coastal flood zones from South Florida to the mid-Atlantic seaboard. This isn't a distant threat. This is happening now. Thwaites is cracked, calving, and slipping from its anchor to the bedrock below. Every month it sheds billions of tons of ice into the Southern Ocean. Every year, the fractures widen. Scientists describe it as unmoored, a massive cork slowly loosening from a bottle it has plugged for thousands of years. The Gulf Coast, the Carolina shore, Miami, Charleston, Norfolk, Savannah, all in the path. But here's what almost no one outside the research community understands. When Thwaites goes, the United States doesn't just get the global average sea level rise, we get more, significantly more. To understand why and how close we are, we need to look at what scientists discovered this year and what they're seeing beneath the ice now. In 2023, a robotic submarine deployed by the International Thwaites Glacier Collaboration captured the first ever images of the glacier's underside. What it found stunned the entire research community. Warm ocean water, intruding miles inland beneath the ice shelf, melting Thwaites from below at rates faster than the models had predicted. NASA, NOAA, and the British Antarctic Survey have all confirmed the findings. The data is unambiguous. The glacier's grounding line, the literal anchor that holds it to the seafloor, has retreated more than 8 miles in the past 3 decades alone. And that retreat is still accelerating. Not slowing, not stabilizing, accelerating. This isn't a theoretical future event. It's measurable, observable, happening in real time beneath the Ross Sea. The institutions tracking Thwaites don't use the word collapse lightly, but they're using it now. Before we go further, let me tell you exactly what this video will and won't do. This video will cover the science of Thwaites destabilization, the physics of why U.S. coasts face disproportionate impact, institutional sea level projections for specific American cities, the honest debate about when, not if, and what individuals and communities can do. No hype, no guessing. Just the research, the numbers, and the stakes as institutions currently understand them. I know the title sounds dramatic, but I'll show you why scientists privately call this the Doomsday Glacier, and why that nickname, as extreme as it sounds, is technically accurate. You'll get the facts, the science, real timeline and uncertainties, and actionable information to protect what matters. But first, a quick ask while I have your attention. If you live on or near the U.S. coast, anywhere from Texas to Maine, I want to know, have you noticed higher king tides, streets flooding on sunny days, or coastal erosion in recent years? Tell me your city and what you've seen. Most people have no idea this glacier exists, but your neighbors need this information. Hit subscribe and like this video to help the algorithm reach people in Gulf and Atlantic states in the path, but don't know it. Your engagement determines who sees this. The more people who know what's coming, the better we prepare. Now, let's go back to the beginning, because Thwaites didn't become the Doomsday Glacier overnight. The story begins in 1992, when humanity first gained the eyes to see Antarctica clearly. NASA launched Topex Poseidon, the first satellite capable of measuring ice elevation to within inches from space. For the first time, scientists could watch the entire continent, every glacier, every ice sheet, with precision that revealed changes invisible to the human eye. Thwaites Glacier appeared unremarkable in those early images. Massive, yes, 120 miles wide where it met the sea, stretching 450 miles inland across West Antarctica. But stable, ancient, the kind of geological feature that had endured for millennia without dramatic change. Scientists cataloged it, measured it, and moved on to more obviously dynamic areas. Then, in 1994, something caught their attention. Dr. Eric Rigneau, a glaciologist at NASA's Jet Propulsion Laboratory, was analyzing satellite data when he noticed something odd. Thwaites' surface elevation had dropped. Not dramatically, just a few inches across vast areas. Measurement error, perhaps. Seasonal variation. Ice sheets rise and fall with snowfall and melt cycles. Nothing to worry about. But the dropping didn't stop. By 1996, the elevation loss had accelerated. By 2000, satellite measurements showed Thwaites flowing toward the ocean 20% faster than it had in 1992. The glacier wasn't just shrinking, it was speeding up, like a car rolling downhill with no brakes. What was causing this? The first major clue came from radar. In the early 2000s, ice-penetrating radar revealed something that would change everything scientists thought they knew about Thwaites. The glacier didn't rest on solid ground above sea level, like most Antarctic ice. Instead, it sat on bedrock hundreds of feet below sea level. And that bedrock sloped backward, away from the ocean, like a ramp leading downhill toward the continent's interior. This is called a marine ice sheet. And marine ice sheets, scientists realized with growing alarm, have a catastrophic weakness. Picture a cork in a wine bottle. If you pull the cork partway out, the remaining portion is narrower, easier to grip, easier to remove completely. Thwaites was like that cork, but in reverse. As warm ocean water melted the edges, the glacier retreated onto deeper bedrock, exposing more ice to the warm water, accelerating the melting, forcing more retreat. A feedback loop with no natural stopping point. The evidence mounted through the 2000s. NASA's Operation Icebridge. Aircraft equipped with ice-penetrating radar flew mission after mission over Thwaites, mapping the bedrock beneath. Each flight revealed the same terrifying pattern. The bedrock sloped backward for dozens of miles inland. If Thwaites started retreating significantly, there was nothing to stop it until it reached bedrock above sea level, hundreds of miles into the continent's interior. But scientists needed to know what was happening underneath the ice. They needed to get close. In 2018, the International Thwaites Glacier Collaboration began the most ambitious Antarctic research project in decades. Teams from the United States, United Kingdom, Finland, and South Korea deployed to the most remote, dangerous corner of the continent. They drilled through half a mile of ice, deployed sensors into boreholes, and listened to the glacier with equipment sensitive enough to hear ice crystals cracking. What they heard was terrifying. Constant creaking, groaning, the sound of ice under massive stress, fracturing and shifting as the glacier's structure changed beneath their feet. Lead scientist Dr. Brittany Schmidt described standing on Thwaites as living inside a building that's slowly collapsing around you. But the most shocking discovery came in 2019, when researchers at NYU deployed ice-penetrating radar from the surface and found something that shouldn't exist. A cavity under the floating ice shelf the size of Manhattan, 2/3 the area of Manhattan, 1,000 feet tall. Empty space where solid ice should be, carved out by warm ocean water flowing underneath the glacier. The water was eating Thwaites from below. In 2020, researchers confirmed the source. Circumpolar deep water, a layer of relatively warm seawater that circles Antarctica at depth, was finding pathways under the ice shelf and reaching the glacier's grounding line. The grounding line is the literal anchor, the point where ice meets bedrock and holds the entire structure in place. The anchor was melting. The submarine footage from 2023 provided the final, undeniable proof. Cameras beneath the ice shelf captured warm water flowing like a river under the glacier, carving channels and cavities at rates far exceeding what computer models had predicted. Scientists watched, in real time, as chunks of ice the size of buildings broke away from the ceiling above them and tumbled into the dark water below. Dr. Kia Riverman, who analyzed the submarine data, put it simply, "We're not watching a slow process anymore. We're watching active destruction." The detective story was complete. Thwaites Glacier, stable for thousands of years, was coming apart in the span of a single human lifetime. The ocean had found its weakness, exploited it, and begun a process that could not be stopped by any technology humans possess. That discovery forced a single question to the center of climate science. What happens when the anchor fails completely? The name Doomsday Glacier sounds dramatic, but it's technically precise. Thwaites Glacier contains enough ice to raise global sea levels by more than 2 feet if it collapses entirely. 2 feet from a single glacier. That's roughly 4% of all global sea level rise happening right now, every year, just from Thwaites alone. To understand the scale, picture this. Thwaites is the size of Florida, or Great Britain. It's not a small ice cube melting in your drink. It's a frozen continent the size of an entire U.S. state, and it's becoming unstable. But here's what makes Thwaites truly dangerous. It's not just the ice it contains. It's the ice it's holding back. Thwaites acts like a cork in a bottle, blocking the flow of even more ice from the West Antarctic ice sheet behind it. If Thwaites fails completely, it could trigger the collapse of surrounding glaciers containing enough ice to raise sea levels by 10 feet total. 10 feet. 2 feet doesn't sound catastrophic, until you realize that every inch of sea level rise pushes the high tide line inland by roughly 6 feet on a flat coast. 2 feet of sea level rise means 12 feet of shoreline lost, and storm surge stacks on top of that new baseline. The mechanism destroying Thwaites is called marine ice sheet instability. Think of it like a wedge being driven into a log to split it. The deeper you drive the wedge, the easier it becomes to drive it deeper. Thwaites sits on bedrock that slopes backward, away from the ocean, like a ramp leading downhill. As warm water melts the edges, the glacier retreats onto deeper bedrock. More ice surface gets exposed to warm water. Melting accelerates. The glacier retreats faster onto even deeper bedrock. It's a positive feedback loop. Positive meaning self-reinforcing, not good. Each step makes the next step easier and faster. There's no natural mechanism to stop it once it begins in earnest. The grounding line, where ice meets bedrock and anchors the glacier, has already retreated 8 miles in 3 decades. As it retreats, more ice becomes floating ice shelf instead of grounded ice. Floating ice melts much faster than grounded ice because warm water can reach it from below. The process accelerates with each mile of retreat. But here's the part that makes this specifically catastrophic for the United States. When Thwaites melts, we don't get the global average sea level rise. We get more, significantly more. This is called sea level fingerprinting, and it works because of gravity and ocean currents. Thwaites' enormous mass, trillions of tons of ice, exerts gravitational pull on the ocean water around Antarctica. That pull keeps water closer to the glacier. When the ice melts, that gravitational pull weakens. The water has to go somewhere. Where does it go? Ocean currents and Earth's rotation distribute that water unevenly around the globe. The Atlantic meridional overturning circulation, the system of currents that includes the Gulf Stream, carries a disproportionate amount of that displaced water directly toward the U.S. East Coast and Gulf Coast. NOAA studies confirm it. USGS models predict it. University research from Columbia, Harvard, and MIT all point to the same conclusion. When Thwaites collapses, U.S. shorelines will see 25 to 30% more sea level rise than the global average. Think about that. If Thwaites alone contributes 2 feet of global sea level rise, the U.S. coast gets roughly 2.5 feet from one glacier, on top of all the other sources of sea level rise happening simultaneously. The real danger isn't in Antarctica. It's in Miami, it's in Charleston, it's in Norfolk, Savannah, New Orleans, Houston, and every coastal community from Texas to Maine. Those cities are in the gravitational shadow of a collapsing ice sheet. And when that shadow shifts, the water has to go somewhere. The physics is unforgiving. The geography is fixed. The only variable is time. So let's talk about what that actually means in feet, in dollars, and in American cities you know by name. When Thwaites was named in 1967, the U.S. coastline was a fraction as developed as it is now. Coastal Florida had 2.8 million residents. Today, it has over 21 million. Nationally, more than 40% of Americans, nearly 130 million people, live in coastal counties that will face the direct impact of Thwaites' collapse. Let's get specific about what that means. Greater Miami alone, nearly 6 million people. NOAA's sea level projections for South Florida show that even 1 foot of additional rise makes king tide flooding routine across Miami Beach, Coral Gables, and downtown Miami. 2 feet, Thwaites' contribution alone, renders much of Miami Beach functionally uninhabitable. The luxury condos, the art galleries, the hotels that define the city's economy. Underwater, at high tide. New Orleans, 1.3 million people in the metro area, most already living below sea level behind levees designed for sea levels from the 1960s. The Army Corps of Engineers flood protection assumes storm surge hitting from the current baseline. Add 2.5 feet from Thwaites, and Hurricane Katrina's 28-foot surge becomes a 30-foot surge, hitting a city that's sunk even lower in the decades since. Charleston, 800,000 people in the metro area. USGS studies show that 2 feet of sea level rise puts the historic downtown underwater during regular high tides. The cobblestone streets, tourists photograph, the antebellum mansions, the waterfront markets, submerge twice daily. Norfolk, 1.8 million people, plus the largest naval base in the world. NOAA projects that by mid-century, current sea level rise trends, before factoring in Thwaites, will flood the base's piers and runways during storm events. Add Thwaites' contribution, and you're talking about permanent relocation of critical national security infrastructure. The list continues down the coast. Savannah, 400,000 people, with the Port of Savannah, 4th largest container port in North America, facing regular tidal flooding. Houston Galveston, 7.1 million people, with petrochemical facilities designed for current sea levels suddenly vulnerable to routine storm surge. Tampa, 3.2 million people, where 2 feet of rise eliminates much of the West Shore business district. The New Jersey Shore, 1.2 million year-round residents with boardwalks and beach towns that generate billions in tourism revenue facing permanent inundation. Lower Manhattan, where 2 feet of sea level rise means the subway system floods, not just during hurricanes, but during ordinary high tides combined with normal storms. The economics are staggering. NOAA and USGS project that Thwaites level sea level rise will affect $14.2 trillion in current property value along U.S. coasts. Not damage, effect. That includes properties that become uninsurable, highways that flood regularly, airports that close during high tides, and entire neighborhoods that require managed retreat. But the visceral reality goes beyond property values. Picture flooded subway tunnels in New York, not during hurricanes, but every month during spring tides. Highway closures along I-95 through South Carolina and Georgia as tidal flooding overwhelms storm drains. Mortgages that become uninsurable, trapping families in homes they can't sell and can't afford to protect. In South Florida, saltwater intrusion into the Biscayne Aquifer, Miami's primary source of drinking water, accelerates as sea levels rise. The same salt water that floods the streets seeps underground and contaminates the wells. 6 million people suddenly dependent on desalination or water trucked in from inland. This isn't a 2100 problem. NOAA's latest projections show measurable acceleration of sea level rise beginning in the 2030s. The impacts start decades before total collapse. Every inch of rise that precedes the main event makes coastal flooding more frequent, more destructive, more expensive to manage. And here's the most disturbing contrast. While scientists track Thwaites' accelerating destabilization, coastal development continues exploding. Florida added 1,000 new residents daily in 2023. Luxury high-rises continue rising along Miami Beach. New subdivisions sprawl across barrier islands in the Carolinas. Houston expands further into flood-prone areas. We're building a civilization in the path of a predictable disaster, then acting surprised when projections show catastrophic impacts. The people moving to these areas, buying these properties, investing in these communities, most have never heard of Thwaites Glacier. They're making 30-year mortgage commitments based on the assumption that the coast will remain stable for decades. They're building retirement plans around Florida condos and Carolina beach houses that NOAA's own data suggests may be routinely flooded within their lifetimes. Now, before this sounds like a doomsday countdown, let's talk about what scientists actually know, what they don't, and where the honest debate sits right now. Let me be completely clear about something. No one can predict the exact timeline for Thwaites' collapse. Not NASA, not NOAA, not the British Antarctic Survey. Anyone who claims to know precisely when this will happen is guessing, and good science doesn't guess. The range of legitimate scientific projections is enormous. Some models suggest substantial collapse could begin within decades, potentially as soon as the 2040s if current acceleration continues. Others suggest centuries, depending on variables we can't control: ocean temperature trends, snowfall accumulation in Antarctica's interior, and feedback mechanisms we don't fully understand. The core scientific debate isn't whether Thwaites will collapse. It's about timing and triggers. Some researchers at the British Antarctic Survey, led by teams analyzing the submarine data, argue that Thwaites has already entered runaway collapse. The retreat is accelerating, the warm water intrusion is expanding, and no natural mechanism exists to reverse the process once marine ice sheet instability begins in earnest. Other scientists, including modelers at USGS and some university teams, take a more cautious view. They see Thwaites in a decades-long, slow-motion destabilization that could still stabilize. If ocean warming pauses, or if changes in Antarctic weather patterns increase snowfall enough to offset the melting. It's happened before in geological history, they note. Ice sheets can retreat and then recover. Let me debunk some bad headlines you've probably seen. No, Thwaites will not collapse next year or cause 10 feet of sea level rise by 2050. Those are misreadings of worst-case scenarios or cherry-picked quotes taken out of context. The most aggressive, legitimate timelines still place major collapse decades away, not years. Here's what we genuinely don't know. The precise bathymetry, the shape of the bedrock, under critical areas of the glacier. Some sections remain unmapped. We don't know if future volcanic activity under the ice will accelerate melting. We don't understand all the feedback mechanisms between ice loss, ocean circulation, and regional weather patterns. We can't predict exactly how Antarctic snowfall will change as global temperatures rise. Most importantly, we don't know the exact tipping points. At what rate of retreat does slow-motion destabilization become runaway collapse? At what ocean temperature does the feedback loop become irreversible? These are the critical questions, and honest scientists will tell you we're still gathering the data to answer them. But here's what every single climate model agrees on. Thwaites will contribute major sea level rise this century. The question isn't if, it's how fast. Even the most conservative projections, the ones that assume optimal conditions and slow retreat, still show significant sea level contribution from Thwaites by 2100. And here's the uncomfortable truth buried in that uncertainty. The floor of even conservative estimates is still catastrophic for U.S. coastal communities. If Thwaites contributes only 1 foot of sea level rise instead of 2, South Florida still faces routine tidal flooding. If it takes 80 years instead of 40, people buying coastal property today will still see the impacts within a normal mortgage timeframe. The uncertainty offers some relief. Maybe we have more time than the worst-case scenarios suggest. But it also offers a different kind of dread. We're making irreversible infrastructure and development decisions right now based on incomplete information about a threat we know is coming but can't precisely time. The conservative scenarios buy us time. They don't eliminate the problem. Embedding our coastal civilization on the hope that the optimistic scenarios prove correct while continuing to build in harm's way is a gamble with stakes too high to justify. And that uncertainty, that gap between soon and eventually, shows up in how different societies are responding right now. Nature sets the intensity of the threat. Human choices set the casualties. Consider 2 different responses to the same rising seas. The Netherlands faces identical sea level rise projections as U.S. coastal areas. Their response, $24 billion invested In the Delta Works, massive storm surge barriers, elevated development standards, managed retreat from the most vulnerable areas, and some of the world's strictest coastal zoning laws. No new construction below certain elevation thresholds. No exceptions. London built the Thames Barrier, a movable flood defense system that closes when storm surge threatens the city. Venice completed MOSE, a system of 78 mobile barriers that can seal off the entire lagoon. Singapore plans to spend $60 billion over decades on coastal adaptation, including seawalls, elevated districts, and floating neighborhoods. Now consider the U.S. approach. In the same decade, the Netherlands raised billions for seawalls. Florida added luxury condos to barrier islands that NOAA says will be tidally flooded by mid-century. Lee County, where Hurricane Ian devastated Fort Myers Beach, approved 61,000 new housing units in flood zones between 2010 and 2020. Miami-Dade County continues permitting high-rise development in areas FEMA maps show as flood-prone. Florida's population grew by 2.9 million people in the past decade, with the highest growth rates in the counties most vulnerable to sea level rise. Federal flood insurance through NFIP subsidizes this risky development, keeping insurance rates artificially low in areas where private insurers refuse coverage. Local governments approve the projects because they generate tax revenue today, even though FEMA and the Army Corps of Engineers have studies gathering dust that show these same areas becoming routinely flooded within decades. You're not crazy for thinking this doesn't add up. The federal government funds research documenting the threat while simultaneously subsidizing development in the threat zone. State governments promote coastal tourism and real estate development while their own emergency management agencies plan for climate-driven displacement. Local governments approve subdivisions on land. Their own sea level rise assessments show underwater by 2060. The Netherlands rebuilt their relationship with water after devastating floods in 1953. They chose adaptation over denial. London learned from the Thames flooding of 1928 and built barriers before the next disaster, not after. Venice waited until the city was flooding regularly, but they ultimately chose engineering solutions over abandonment. The United States continues building in harm's way while the harm accelerates toward us. Adaptation is possible. The engineering exists. The models work. But adaptation requires political will, long-term thinking, and acceptance that some areas simply can't be defended economically. It requires making hard choices now to avoid catastrophic choices later. So what does that mean for you personally, for your family, your home, your future? You can't control Thwaites, but you can control how prepared you are for what's coming. Here's what that looks like practically. Individual level, know your flood zone. FEMA's flood map service shows current risk, but also check your state's sea level rise projections through 2050. If you're buying property, don't just consider today's flood risk, factor in where that property sits relative to projections 20 to 30 years out. A house that's safe today may be in a flood zone by the time you pay off the mortgage. Get flood insurance or verify your coverage. Most homeowners' policies exclude flood damage. The National Flood Insurance Program covers up to $250,000 for residential structures, but that may not cover full replacement costs in today's market. Private flood insurance exists and sometimes offers better coverage. Compare options. Build a family communication and evacuation plan. Know multiple routes out of your area. Designate an out-of-state contact person. If you're renting, know your building's elevation relative to local flood levels and understand evacuation procedures. Keep basic supplies, water, batteries, flashlights, important documents in waterproof containers, and cash. Standard hurricane prep applies to sea level rise impacts because the infrastructure failures are similar. Systemic level, attend local planning and zoning meetings. Push your city council and state representatives to adopt updated sea level rise projections in infrastructure planning and building codes. Most local governments still use outdated flood maps and elevation requirements. Support candidates who prioritize climate adaptation and managed retreat over short-term development revenue. Ask specific questions about sea level rise planning during candidate forums. Some communities are already adapting. Norfolk has integrated sea level rise into all infrastructure planning. Annapolis is piloting adaptive building codes. Find these models, understand what works, and advocate for similar approaches in your area. The key is scale and timing. Individual preparation protects your family. Systemic advocacy protects your community. Both are necessary, and both require starting now, while there's time to adapt rather than just react. You can't control Thwaites, but you can control whether your family has a plan, whether your community has a voice, and whether your elected officials are building for the coast we'll have, not the one we had. Let me bring this home. Thwaites Glacier is going to melt. That's geology. But whether 10 million Americans are displaced in chaos, or whether we adapt, protect the vulnerable, and manage the transition, that's a choice we make in the next 10 years, not the next 100. The disaster is nature. The death toll, the economic ruin, the equity of who suffers most, Those are human decisions made right now in city councils and insurance offices and voting booths and family conversations around kitchen tables across coastal America today. This is heavy information. It's completely okay to feel that weight on your shoulders. But here's the reframe. Knowledge is the first step toward real agency and preparation. You now know something most of your neighbors still don't. You understand a threat that will reshape American geography within your lifetime. That knowledge makes you part of the solution, not just a victim of the problem we all face together right now. Tell me where you live on the coast and whether your city is preparing or ignoring this threat. I read every single comment carefully. Your local experience truly matters to this important conversation. Other viewers in your area need to hear what you've actually seen firsthand. Subscribe to stay ahead of the curve on the next major threat we'll cover here. Hit the like button so this reaches more people in the blast radius. Share this with someone in a coastal city who truly needs to know what's coming next. The glacier is slipping. The ocean is rising. The only question left is whether we'll all be ready when it finally arrives on our shores.